Hey everyone, welcome to Practically. We bring learning alive. So, what is today? So, today we are going to discuss about sample paper 1 chemistry of class 9th. Yes, so again, we all welcome you on Practically, and our motto is to bring learning alive. Yes, first of all, we should know about what Practically is. So, here something about Practically. That Practically is India's first experiential learning app for class 6 to 12 that enables STEM learning through immersive videos, interactive simulations, and augmented reality. So, what are our features like lifelike video content we provide? We experiential learning we provide, augmented reality learning, interactive simulations, live classes online, coding classes for children, AI assisted learning, study plan. Hey, good evening, Chaya Devi. How are you? So that how we provide, look at how much we are providing. So just go and enroll for your live classes on Practically. So the next question is, how can we enroll on Practically for live classes? So here's the steps you should follow. Click on the Practically app. Go on the sample paper and PYQ term 1 CBSE, and when you click on it, then you find two options, enroll and info. So for you just click on enroll, you get enroll and you find all your class materials at the material section here. Okay, so this is what about Practically is and how to enroll in Practically. Now, if I talk about sample papers, so this is our schedule for sample papers class 9. So, hey Nishant, good evening. How are you? Okay, Chaya Devi says, fine, ma'am. It should be great, ma'am. I'm very great. I'm very good. Only fine. Okay, so here sample paper 1 chemistry discussion that is on today 5 November on Friday we are taking, and next our chemistry sample paper 2 discussion will be held on 11 November, that is your Thursday. Okay, now so the class timings are 5:30 p.m. and now I am going to start this sample paper discussion, and the first questions appear on the screen right now, and here is the first question. Now tell me, in the lab we prepare two solutions. Okay, Nishant says I am great, ma'am. That's really good answer. So in the lab we prepare two solutions, one of NaCl in water and another is starch in water. With the help of torch, both the solutions were tested for Tyndall effect. The result obtained was solution of NaCl shows Tyndall effect. This is option A. B. Solution of starch showed Tyndall effect. C. Both the solutions show Tyndall effect. Or none of the two solutions shows Tyndall effect. So let's check how you have cleared this concept of Tyndall effect, how much you know about this Tyndall effect. That when you are provided with two solutions, that one solution is of your salt in water, that is NaCl in your water, and another one is your starch in water. So which of the following will show Tyndall effect? Either both, either none, either NaCl or starch solution. What do you think? Okay, Nishant is saying first C and then B. What is it? Okay, so it's B, option B. So Nishant says solution of starch shows Tyndall effect. What about Chaya Devi? What do you think? Which is the correct answer? So if I say Nishant, you are absolutely correct. So starch solution shows Tyndall effect. Why? Why? The scene is why. Why starch only shows Tyndall effect, not NaCl? Because when we dissolve salt in water, it will be forming a true solution. Yes, it will be forming a true solution. And we know that true solution does not have the size of particles bigger enough to scatter the light. We know Tyndall effect is the scattering of light by the particles of the solution. So here NaCl does not have the size of particle bigger enough that they can scatter light. But in starch solution, that is starch in water, we are having starch solution bigger enough, starch particles bigger enough. Solutions don't show Tyndall effect. That's correct. That's correct, Nisha. And Chaya Devi is saying option C. No, both solution can't show Tyndall effect because NaCl in water is your true solution, and we know that true solution have a smaller size particle which does not or which cannot scatter the light of beam or the beam of light. So here starch in water can scatter the light because the particles are bigger enough to scatter the beam of light. So here option B is correct. Very good. Next question on your screen. Yes, start solution is your colloidal solution. Very good. You are at good speak. I must say that you are very good at this. Now, second question. Second question. What do you think? Iron fillings and sulfur powder were mixed and heated strongly. After cooling, the product was stacked with a magnet. No iron filling were separated. The product thus formed was, it is an element, it is a mixture, it is a compound, it is an alloy. So basically the question is, if we are having iron and sulfur, when we mix it together, we will be having FeS when we heat it. Now, we just move a magnet over this mixture. We just move a magnet over this mixture and the iron fillings were not separated out. Why? What will be the reason? Is it FeS is an element, it is a mixture, a compound or an alloy? I will give you shorty that after doing this session 1 sample paper discussion, you will get concept crystal clear. Okay, your concepts will be crystal clear about 70% of your concept. Okay, so listen it carefully, answer it whether it is wrong or right. Doesn't matter. Just matter is that you learned something. Okay, so Nishan saying option C, it is a compound. That's correct. It is a compound. Why compound? Because we know the definition of compound. That compound does not show its constant properties, while a mixture do. Why we are not saying that FeS is a mixture? Why we are saying that it is a compound? Because FeS cannot show its constant properties like we are having iron and sulfur. It does not showing its iron property because when we move the magnet upward this mixture, then all the iron filling should attract it towards it. But it is not happening. Why? Because it is a compound and compound does not show its constant properties. So here option C will be the correct answer. Heating iron fillings and sulfur will make a compound. That's correct. This is one more thing. If we just take iron filling and sulfur, then it will be only mixture. Then you move a magnet and it get attracted. But if you heat this mixture, now it will no more remain this mixture part. It will be converted into compound. Okay, that's why it does not show its constant properties. So, next question. For separating cream from milk, which of the following techniques will be used? Is it chromatography? Is it evaporation? Is it centrifugation? Or none of the method will be used for separating cream from milk? So, what do you think? Let's see the answer. Yes, that's correct. Nishant, centrifugation. That's correct. That's correct. Why Chaya Devi is not answering? Either you give right or wrong, doesn't matter. Just answer it. Whatever is the answer. Okay. So just learning is important. It is not important that you give right or wrong answer. Okay. So for separating cream from milk, which separation technique we will be using? We will be using, yes, centrifugation. Kartika also saying centrifugation. So very good, very good. Centrifugation is a technique which is used to separate cream from milk. We go to a shop and we ask for the shopkeeper that I want a full cream milk. Yes, I want a full cream milk or I want a toned milk. What does that mean? That means full cream milk will contain the cream in it. The milk is containing the cream. But in your toned milk, the milk we are having does not contain any cream. So what they do, they just follow the procedure of this centrifugation. So can you tell me what is the principle of centrifugation? Or what is centrifugation? Can anybody tell me? Just I want to wait for the answers. So Kartika, Nishan, Chaya Devi, can you tell me what is the principle or what is the definition of this centrifugation? What is this procedure? Just write it. It works on centrifugal force. That's correct. That's also correct. Good, Kartika. And Nishant, where is your answer? Chaya Devi, where is your answer? I am waiting for your answer. Okay, I will tell. Denser particles are forced to the bottom and lighter particles stay at the top. Bingo. Very good. Nishant, very good. So basically what happens in your centrifugation process, that when we rotate the mixture at a very fast speed, then what will be happen on it, that the denser particle just remain at the bottom and the lighter particle stays at the top. That means the milk which we are the cream and milk which we are separating, then what will be happen, the milk which is denser will be at the bottom and the cream will be at the top as it is having lighter particles. So centrifugation is a process in which we just spun the centrifuge tubes very fast and the denser particle are goes to the bottom and your lighter particles stays at the top. That's correct. Very good. Now, next question. When an iron nail was put into copper sulfate solution, after some time, we had observed reddish-brown deposit on the iron nail. The deposition was of sulfur, oxygen, iron, copper. What do you think? What is this deposition is? Is it of sulfur? Is it of oxygen? Is it of iron? Is it of copper? What do you think? So, I will just explain the question what it says, that we are having copper sulfate solution. Now, in this copper sulfate solution, it is blue in color. Now, we put an iron nail into this solution. Now, after some time, we see that there is a brown colored deposit. What is this brown deposit? Oh, I just write the answer. So, what is this brown colored deposit here? Okay. Everybody answered. So copper says by Nishant. Kartika also says copper dye to electroplating. Yes, that's also used for copper dye to electroplating. So very good, Kartika. So here copper sulfate is your blue in color. Okay. Now this iron, this is your iron, that is Fe. So here Fe displace this copper and will be forming FeSO4, and this copper will get deposited on this iron. Okay, this will be get deposited on this iron. Can you see this image? Now this blue color copper sulfate solution will be turned into green your iron sulfate solution, and your iron nail will become brownish in color due to the copper metal deposition on this iron nail. Okay, so the copper will be the correct answer. Very good, Kartika and Nishan. And I want answer from Chaya Devi also. Why she is not answering? She give right answer. Okay. So next, fifth, in tincture of iodine, find the solute and solvent. In tincture of iodine, find solute and solvent. Alcohol is the solute and iodine is the solvent. Iodine is the solute, alcohol is the solvent. This is option B. Option C, any component can be considered as solute or solvent. And option D, tincture of iodine is not at all a solution. What do you think? Okay, Kartika says B, iodine is solute and alcohol is solvent. Okay, let's see the answer. So, I want more answers. Where is Nishant? Where is Chaya Devi? I want answers from you also. So here, in tincture of iodine, iodine is solute, alcohol is solvent. Okay. So let's see the answer. That's correct. Kartika and this Nishant gives absolutely correct answer. So here, first of all, we need to understand the solution. Whenever we are having any solution, then it will consist two medium. That one is your solute, another one is your solvent. If I talk about the solute, then solute is generally present in your smaller amount and the solvent is generally present in your larger amount. Okay, so here in tincture of iodine, we are having iodine and alcohol. Iodine as a solute and alcohol as a solvent. And this make our tincture of iodine as a solution. Okay. Now, if we put camphor in an open container, its amount keep on decreasing. Its amount keep on decreasing due to the phenomena of A, evaporation, B, precipitation, C, condensation, D, sublimation. So what's your answer? So Kartika is saying, hello ma'am, I am Lakshmana Prabhu from Tamil Nadu. Okay. So I will be calling you Lakshmana Prabhu from now on. Okay. So Lakshmana Prabhu also says sublimation, that is solid to gas, and yes, that's correct. Sublimation. Why sublimation and what is this sublimation process is? So sublimation is converting solid to gas. And also you find this gas to solid also. But the more appropriate word or the procedure we can say is your deposition from gas to solid. So basically we say solid to gas as sublimation and gas to solid as deposition. If you say solid to gas and gas to solid as a sublimation process, then it's also correct. Okay. Now, if we put a camphor in an open container, its amount keep on decreasing due to the phenomena. Camphor is your solid, is in solid state. And when you kept in an open container, then it will directly convert it into gas or into vapors. Now, we know that whenever there is a change of solid state to gaseous or vapor state, then there will be the process of your sublimation. So that's why it undergoes sublimation process. Can you tell me another example of sublimation? Can you tell me another example of sublimation which undergoes sublimation process? Or just I can say the sublime substances. Can anybody tell me? Okay, let's wait for your answer. Till then, I am moving towards the seventh question. Sol and gel are examples of. Sol and gel are example of. Yes, that's Lakshmana Prabhu naphthalene balls. Very good. Even one more example, ammonium chloride. Remember this example also, as it is very important and it will be asked in your question again and again. So, next question, sol and gel are examples of solid-solid colloids, sol in a solid-liquid colloid, and gel is liquid-solid colloid. Third, sol is solid-solid colloid and gel is solid-liquid colloid. Fourth, sol is liquid-solid colloid and gel is a solid-liquid colloid. What do you think? Sol and gel are example of which types of colloid? So, for this, okay, Nishan says B, Lakshmana says also B. So, here answer is B. That's correct. Why? First of all, you need to understand something that we are having different types of colloid system. So here, if we are talking about sol and gel, this is the image of your NCRT table. Okay, so you just need to mug up this table and not other than this example will be asked in your. Okay, Chaya Devi also says B. Ma'am, I have exam tomorrow and you are very good at preparation, Nishant. Very good at preparation. So this will also boost your preparation. Okay, I hope you find it very useful in your exam. So all the best. So here, if I talk about colloidal system, then we are having dispersed phase and dispersion medium, and then we are having types of colloid. If I talk about dispersed phase, then it is like your solute and dispersion medium is like your solvent. Then we are having sol type of colloid. Now look at this. This is your sol and we are having dispersed phase as solid and dispersion medium is liquid. Okay, so examples are paint, cell fluids. These are the examples of sol. If I talk about gel, then this is your gel. And we are having dispersed phase as liquid and dispersion medium as your solid. So gel is a liquid and solid type of colloid and sol is your solid and liquid type of colloid. So get the difference between this dispersed phase and dispersion medium. So you need to mug up or just remember some example so that you just click on your mind that okay, this type of colloid is formed. Like if I talk about smoke, then it is a type of, you can see, it is a type of your aerosol. And if I say about aerosol, then it will be solid in gas. That means we are having solid as a dispersed phase and gas as your dispersion medium. And we can see the dust particles, the carbon particles which are in solid state and your air as your in your gaseous state. So here we can remember this that smoke is an aerosol and aerosol is something that having dispersed phase as solid and dispersion medium as gas. Okay, so this you need to mug up this whole table. So whenever there is any question asked from here, you just click on the right answer and gain your marks. Yes. Now moving towards 8th question. Which of the following are physical change? First, melting of iron metal, rusting of iron, bending of an iron rod, drawing a wire of iron metal. So you have seen these option A, B, C, D. What do you think? Which of the followings are the examples of physical change? Can any example of any type of colloid come outside from this table? So if I say for now that no, they won't ask in your CBSE exam, that board exam, they don't ask from the outside table. So you just need to mug up this. But sometimes scenarios are created. Then what do you think? Just think about the dispersed phase and dispersion medium. What could be the dispersed phase and dispersion medium? Let's say you don't remember this table and suddenly asked what is the smoke? Which type of colloid is this? Then you need to know that we are having air in our atmosphere, which is your gaseous phase. Then we are having dust particles in smoke and carbon particles, which will be your dispersion phase. Okay, dispersion phase as your solid. So carbon and dust particles and dust particles. So you just think of it that whenever we are having solid in your gaseous medium, then it will be forming aerosol. Okay. So Kartika saying option C. Option C. Chaya Devi is first saying A and then C. Okay, let's say, C. So she is saying C. So here we are having physical changes, melting of a iron metal, rusting of iron, bending of iron, or drawing a wire of iron metal. Let's see the answer. So option C is the correct one. Very good. Very good. So here, why physical changes are this first, third and fourth only, not second? First of all, you need to know the difference. The basic difference between a physical and your chemical change, that in physical change, no new substance is formed. But in your chemical change, a new substance is formed with new properties. Okay. In your physical change, only state can change, color can change, only physical properties can change, but your chemical properties remain same. So here, if I talk about melting of an iron metal, then you are just melting it. So melting, like your boiling, these are the process which just change the state of any matter. It does not change its property. So let's say we are having water. It is in solid state, that is we will be considering it as ice. Then we are having water in liquid state. Okay. So now if I talk about this process, then this is your melting. Here it is in solid state. Here it is in liquid state. Now, what happens when we change the state? No new substance is formed. It remains water. Okay, it remains water. Only the physical state change, that it is in solid phase and it will be in liquid phase. Another thing you can observe that in your physical changes, generally changes are reversible. Like we can convert water to solid and solid to liquid again. So these are the reversible changes. But in your chemical change, generally or mostly you can say the changes are irreversible. So melting of iron metal is your just a physical change. Rusting of iron. What do you think rusting of iron? It will be forming a new substance Fe2O3.XH2O. Okay, so here the rust, this is your rust, a new product is formed. So it will be your melting. Yes, melting is a physical change. It will be a physical change because no new product is formed. Okay, Nishan? So here iron oxide is rust. Yes, iron oxide is your rust. Here Fe2O3 is your rust. And the water of crystallization will be there, because it will be reacting, your iron will be reacting with water and your oxygen also. So whatever will be the water amount is there, then the water of crystallization will also be there. Okay, so here iron oxide is rust. Very good, Nishan. So here rusting of iron. Here the new product is formed. That's why it is a chemical change. While bending of an iron rod, you just bend it. It is a physical change. No new substance is formed. It is a physical change. Drawing a wire of iron metal. You are just taking a iron metal and drawn into a wire. This is a physical change because no new substance is formed here. So that's why your option C is correct. Okay. Next, metals are ductile. Yes, metals are ductile. That means they can be converted into wire. This is the most confusion I can see in children, that they are confused between ductile and malleability. Okay, so just remember this: ductile means converting into wires and malleable means converting into sheets. Okay, this is additional information I give. So this is the table between physical and chemical change. What I have teach you in the previous slide, that the whole thing is written over here. Okay, chemical irreversible. Yes, physical reversible, chemical irreversible. Which of the one of the following is an example in which physical and chemical change take place simultaneously? Now this is very interesting question. Let's see who will give this answer very correctly. So here is one of the example is there that will be having physical and chemical change taking place simultaneously. Can you answer me this? Is it of burning of candle? It is of cutting of wood? It is burning of paper? Or all of the above? What do you think? Burning of candle. Okay, Nishant. And I forgot the name. So I will be calling Kartika. So burning of candle is chemical. Okay, burning of candle is chemical and melting of it. You know everything. Very good. That's the thing. Burning of candle, in which the two changes take place simultaneously. That is, your physical and chemical change are taking place here simultaneously. So what is happening here? When your wax is melting, here the procedure one is your melting, which is your physical change. As I already told you in the previous slide, that whenever we burn this wax, the procedure is your melting. And here melting is a physical change. Now, if I want to talk about burning of candle or the combustion here take place, the combustion reaction take place, this is your chemical change, because the carbon components and the hydrogen components which are present in the wax, because we know that your wax is containing a hydrocarbon, that is your CXHY you can take. That means it will be having carbon particles, it will be having hydrogen particle, and when this undergoes combustion, the carbon and hydrogen particles can be just vaporized, and here we are having the chemical change. Because at the same time, just look at this thing, at the same time the constant carbon and hydrogen present in the wax react with oxygen of air to form a new substance, that is your hydrocarbons. This means that a chemical reaction or change is also taking place. So here when you burn a candle, then two process takes place simultaneously. First, melting of your wax, that is your physical change, and when this just gets combustion, when your candle undergoes combustion, then it will be your chemical change. Yes. Next, 10th question. This is somewhat about the concept of compound, element and mixture. What do you think about that particular compound, your element and mixture? So here we are having two substances A and B. Listen to me very carefully. We are having two substances A and B. Were made to react a reaction, a third substance A to B was formed. So here we are having A and B. They react together and form a to B substance. So just we are balancing it. So 2A will be there. Now, which of the following statement concerning this reaction are incorrect? Don't be optimistic that you have to find the correct statement. You have to find the incorrect statement. So here the product A to B shows the properties of substance A and B. That means this product will show both the properties of A and B. Second, the product will always have a fixed composition. This product will be having the composition 2:1 and it will remain, or it will show the same composition 2:1. Second, the product so formed cannot be classified as compound. That means this A to B is not classified as compound. Fourth, the product so formed is an element. That means this product is your element. What do you think, which are the incorrect statement? So Nishant is saying statement first, third and fourth. That means your option C. Option C. Okay. So here, waiting for more answer. Kartika, where are you? Where is Chaya Devi? Just answered this question. So let's see. Yes. First, third and fourth. These are the incorrect statement. Why? Ma'am, I don't know answer. That's the honesty. I don't know the answer. Okay, I will explain you. So here, what is this question about? So A and B are two components. They together form A to B. Now, first of all, identify whether it is an element, it is a compound or a mixture. So here, they are not talking about mixture. They are talking about compound and element. Now, A to B will be having 2:1 proportion ratio. 2:1 proportion ratio. That's correct, Nishan. That is, A to B is your compound. Why it is not an element? Because we know the definition of element, that element is made up of same kind of atoms. Let's say A can be element, B can be element because it is made up of only same kind of atoms. But if I talk about A to B, then it will be having two atoms, that is your A and B. Then it cannot be your element. It can be your compound. Now, if it is your compound, then what are the properties of compound? They should have fixed proportion. This is the main thing in compound, that they always have a fixed composition. They should follow the definite proportional mass. Okay, so here, what is the point? That compound are having fixed composition. Compounds are having fixed composition. So first thing, the product A to B shows the properties of substance A and B. No, compound do not show the properties of their constant. Compound do not show the property of their constant. Why? While mixture shows the properties of their constant. Let's say, one example I will be giving you. If I am having hydrogen and oxygen, then water formation will be there. Now, you know oxygen is the best supporter or the necessity for the combustion. But water is not supporter of your combustion. It stops combustion. It will be having an opposite effect. So here, water is your compound. So now, here water is your compound, and you see that water doesn't show the properties of neither hydrogen nor oxygen. As we know that oxygen is the necessity for your combustion, while water is or I can say water does not support combustion. So compound does not show the properties of its constituent. So the first statement is your incorrect. Second will be your correct because compound will be having fixed composition. Third, the products of form cannot be classified as a compound because uh, it is a incorrect statement because it is already a compound. We have already discussed this. The products of form is an element. It can't be an element because element is formed by same kind of atoms. So I hope you get this point, and look how the questions are framed. So simple question, and look how this question is framed. Just you need to know the compound and this element. Okay, if you know this compound and element definition, you just hit it. Just get, if I say it is 4 marks question, you get 4 out of 4. Simply, I can't understand why someone's dislike this. Okay, that's their thought. Yes, ma'am, now I can understand well. That's great. That's great. So here, you get 4 out of 4 just by knowing the definition. Next, a 15% alcohol solution means. What do you think? This 15% alcohol solution means 15 ml of alcohol and 85 ml of water. 15 ml of alcohol, 100 ml of water. See, 15 ml of water and 85 ml of alcohol. Or you can say, can't say anything. Or you just say it is not a solution. What do you think? What do you think? What is the correct answer here? What does this 15% alcohol solution mean? So basically, just think about it. What is this 15%? It's so Nishant is saying A. And what does this Kartika says A? Okay. So that's the correct answer. 15% is your concentration. Is your concentration. And what is concentration percentage? Concentration percentage is your amount of solute in your solution into 100. Yes. Now, this 15 ml will be your alcohol. Okay. This 15% will be your alcohol and 100 will be your solution. You write 15% as 15 by 100. What does that mean? 15 ml is your solute, that is your alcohol, and 100 ml will be your solution. Now, what is the solvent here? Solvent here is water because it is an alcohol solution. That means alcohol contains water. Okay, so or I can say water contains alcohol. So here alcohol is 15 ml here and the whole solution is 100 ml. Then what will be the solvent amount here? So 100 minus 15 will be your 85. So 85 ml of water is there. So 15 ml alcohol, that's your solute, 85 ml your water, and when you mix it, you get 100% of your alcohol solution. So remember this thing. They just can change this digit, this number, this percentage can be changed here. So when they change percentage, you should know what it denotes. It denotes the concentration. If it denotes the concentration, so we need to find the amount of solute and solvent. So the question can be framed in any way. Okay, just you need to remember this thing. Okay, now next question. So here A is the answer. Aerated drinks like your soda water, etc. are dash solution. That is gas in liquid, liquid in gas, liquid in liquid, solid in liquid. What do you think? Aerated drinks like soda water, what are this type of solution is? So Kartika is saying B, that is liquid in gas. Okay. What about Nishant? What about Nishant? Anyone else? Chaya Devi. Where is Chaya Devi? gas in liquid, soda. Okay, so let's see the answer. Yes, correct. Gas in liquid. Whenever we are having this such type of drinks, then we can find this carbon dioxide gas. A brisk effervescence was just come out from the bottle. When we open the bottle cap, a brisk effervescence was come. So it will be having a carbon dioxide gas. And we are having these drinks in your water format. So here, water is your solvent. So you are having this carbon dioxide gas in your water. So it will be gas in liquid. That's why it will be gas in liquid. Why not liquid in gas? Because we are having water as a solvent. Water as a solvent. And here, if we take liquid in gas, then liquid will be your solute and gas will be your solvent. But that's not true. Your carbon dioxide will be in a smaller amount, which will be your solute, and liquid, which is your solvent, here is your water. Okay, yes, fizzy drinks, that's correct. Chaya Devi, now you come. Very good. I want answer from you also. Okay, so it's not B, it will be your option A, gas in liquid. Okay, I hope you understand. Now, this is simple question. Which of the following element is not a metalloid? What do you think? Which is not a metalloid? It is boron, silicon, germanium or tungsten. Which of the following is not a metalloid? What do you think? Come on, answer fast, quickly. Okay, tungsten is a metal. Can Nishant tell me the symbol for tungsten? What is the symbol for tungsten? Okay, Kartika, what's your answer? Chaya Devi, what's your answer? So I will be showing the answer here. Yes, tungsten is not a metalloid. It is your metal. Kartika, correct. W. It's capital W. Okay. So here W is the symbol for your tungsten. It is your metal. And where boron, silicon, germanium are your metalloid. What are metalloids? That having the properties between your metals and non-metals. Okay. Now, this simple question. Now this is again a tricky question. Again about something compound and element and mixture. So here, two chemical species X and Y combine together to form a product P, which contains both X and Y. Here, we are having X and Y. This is very simple question, but asked in a very tricky way. So X and Y, we are having two reactant and it will forming product P. Now, X and Y cannot be broken down into simpler substances by simple chemical reaction. Which of the following concerning the species X, Y and P are correct? So here, what statements are correct about X, Y and P? So here, P is a compound. Second, X and Y are compound. Third, X and Y are element. P has a fixed composition. So which are the correct statements here? Think a little bit and then answer. I will wait for your answer. Just think over it. What do you think about elements and compound? What do you think about this reaction? What is given in the question? Statement 1, 3 and 4. That's option D. Okay. Chand answered option D. And what about others? What about others? Where is Chaya Devi's answer? Where is Kartika answer? So, okay, I will tell you this. Just see how simple this question is. If I talk about X and Y, and it will be forming a product P. Here, X and Y are your Elements or compound? What do you think? You say, ma'am, it can be a compound, it can be an element. But the thing is here, X and Y cannot be broken down into simpler substances by simple chemical reactions. This is the main point here, that we know that elements cannot be broken down into simpler substances. That's why they can be considered as your elements. Because we know if there is a compound, it can be broken down into its constituent particles by chemical reaction, not by physical means, but by chemical means we can separate the constituent. But in element, we cannot broken down into simpler substances. So which of the following concerning the species X, Y and P are correct? So P will be your compound. P will be your compound because X and Y will be reacting together to form any compound. Let's say X or A, XA, YB. I will be forming this type of compound. So here P will be your compound. If P is your compound, then it will be having a fixed composition. Now if I talk about X and Y, then X and Y cannot be compound because compounds can be broken down into simpler substances by chemical means, while elements can't. Okay, so here the option D is correct. Option D is correct here. I hope you got this. So this is how the questions are asked, and look how simple they are. Okay, now 15th question. This is very simple. This is a simple definition. So the continuous zigzag movement of colloidal particle in a dispersion medium is called dispersion, Tyndall effect, Brownian movement or Brownian motion or oscillation. What do you think? What should be the answer? Okay, Kartika is saying C, Brownian movement. Okay, Nishant is saying Brownian motion. That's correct. Brownian motion or movement, whatever you want to say. So here, Brownian motion is the zigzag movement of your smaller particles which are suspended in your liquid or either gas. So here, the dispersion medium can be your liquid or can be your gas. So Brownian motion is the zigzag movement or just a random movement. You just say a irregular or random or zigzag movement of your particles which are dispersed in your liquid or gaseous phase. Brownian motion cannot be shown in your solid phase. Okay? Okay, Chaya Devi. That's good. You answered. On many medicines bottle, it is written, shake well before use. Can you tell me what type of mixture the bottle is containing? Can you tell me what type of mixture the bottle is containing? Pure solution, unsaturated solution, colloid or suspension? What do you think? So Kartika is saying D, suspension. Okay. What about others? I am waiting for your answer. Quickly answer. Suspensions are unstable and settle down, and that means Nishant is saying again option D. Okay. So that's correct. That's correct. The suspension. These are the types of which type of solution they are suspension. So basically we have seen on the bottle that shake well before use. Why? Because they are containing suspensions. And what happens in suspension? That the particles in the bottle, let's say this is your bottle. I am not good at drawing, so just consider it as bottle. So here, what happens when they make a solution? When they make a solution, then after some time, these heavier particles will settle down. Now, these heavier particles are settled down in the bottom, and when we use it, then we need to shake it so that these settled down particles will get suspended into the solution. Okay, that's why one more thing is clear from here. That's why we are saying that suspension may or may not show Tyndall effect. Do you know this point? That suspension may or may not Tyndall effect. Why? Suspension have larger enough particles to scatter the light. But why it is written over there may not? Because some suspension particles will settle down. And when the suspension particles will settle down, then there are no particles in the solution which just disperse or just scatter the light, or the particles are not there to scatter the light and show us the Tyndall effect. So that's why the point is here that it is written in Tyndall effect property that suspension may or may not show Tyndall effect because the particles just settle down in the solution. And when does it show the your Tyndall effect? When the particles are present in your solution. If you continue it stirring, then they can show the Tyndall effect. But after some time, they will again settle in the bottom. Next, on many, yes, it is over. So here is the table for your properties of solutions, colloid and suspension. So this is, you all know, just for your revision, I have made this table. So particle size less than 1 nanometer, colloids having 1 to 1000 nanometer, suspension more than 1000 nanometer. So that means the particle size is very less in your solution, intermediate in colloids, and more in or larger enough in your suspension. If I talk about homogeneity or nature, so remember this, these two words can be used in your property if they are asking for their nature of the solution. Either they are homogeneous or heterogeneous. Remember, colloids are heterogeneous in nature, but they appear as homogeneous. Okay, but they appear as homogeneous. Why? Because they, first thing, they do not mean, or just I can say for heterogeneous and homogeneous, what is the difference? Homogeneous does not have a separation of layer. In some book it is written that the colloids are, yes, there is a very you can say the variation in the colloids. So you will take 1 to 1000 nanometer because 100 will come under this category. Okay, 100 will come under this category. So you can take 1 to 1000, or if you want to take 1 to 100, then it also correct. Because I have also seen this thing that in some books there is written 1 to 100 nanometer and some it is written that 1 to 1000. So take this range. Okay, so basically why they just write, nobody is going to ask what is the size of particle. You should know that in general the solutions are very smaller in size and colloids will be having your intermediate particle size and suspension will be having your greater size. Okay, got this, Nishant? So whatever in the NCERT you can prefer that in the first preference, and if you want to write from 1 to 100, then it will also fine. And if you want to write 1 to 1000, then 100 nanometer will automatically comes to this category. Okay, okay. So Tyndall effect do not show in solution, while colloids can show, and suspension may or may not show. Example, salt solution, milk is your colloid and sand is water in your suspension solution. Suspension, a type of solution. So here, next question. When two liquids do not mix, they form two separate layers. Very, very simple question, but I will make a twist in it. In your, when I will just explain this answer. So here, when two liquids do not mix, they form two separate layers and are known as, it is your miscible liquid, it will be your immiscible liquid, it will be your saturated liquid, or D, it will be your super saturated liquid. So Kartika is saying option B, that is your immiscible liquid. What Nishant thinks, what Chaya Devi thinks, what's your answer? Come on, quickly answer. We are running out time. So the answer is your immiscible liquids. When we are having the separation of layer between two liquids, then they will be considered as your immiscible liquids. When we are having immiscible liquids, yes, correct Nisha. When we are having immiscible liquid, then what type of separation technique we use? That's why I took this question. We are using this separating funnel technique. Why separating funnel? First of all, you should know the principle. So first thing, we are having two liquids which will be having different density. Remember this, different density. If they are having different density, I think chats are shown to you late. Okay, this is happening to me. Okay, so it's okay, you are giving correct answer. Not worry about this thing. So liquid in liquid, whenever we are having liquid in liquid type of solution, then they are having different densities. That means if they are having different densities, they are immiscible liquid. That they can form the separate layer. They are forming the separate layer. So here we are taking two liquids which are having different densities, then they form a separate layer. Then the separation technique we are using is your separating funnel. So see how separating funnel works. So you can see this stopcock. Here water and kerosene are the two liquids we are taking. Now kerosene and water, that is your oil and water, are your just having different density. That water is having higher density than your oil. So it will be take the below position and kerosene will float over the water. Now when I open this stopcock, then we collect this water. The denser particle will come out first. Now when the water is over, then just stop the stopcock. Remove that beaker, put another beaker and just open that stopcock and you get your kerosene oil. Okay, so here the separating funnel will be used when there are immiscible liquid when they are immiscible liquid, then they will be having different densities. Yes, Chaya Devi, that's correct. B is the right answer. Now, how one can separate ammonium chloride from a mixture containing ammonium chloride and sodium chloride? This is the most common question I have seen. That what is the separation technique that we are going to use in ammonium chloride and sodium chloride separation? So we are having a china dish. I have put sodium chloride and your ammonium chloride. Now tell me which separation technique you are using. It's precipitation, it's sublimation, chromatography or centrifugation. So Kartika is saying B. Nishant is saying sublimation. Can we drink the water separated from petrol? Yeah, if we can say that a little amount. If I say I prefer, do not drink it, but I will say this, that you will be having petrol will be floating on water, right? But a little amount of petrol will be present on your upper surface of water. You will find this. Okay, so it will be not suitable for drinking purpose, but yeah, for separation purpose it can work. Okay, so for ammonium chloride and sodium chloride, answer is saying sublimation, that is option B. So Nishant is saying ammonium chloride is your volatile substance. Yes, that can be converted into vapors. So sublimation is the process which we'll be using here, because ammonium chloride is your a sublime substance or a volatile substance that can be converted into vapors, while NaCl, that is your sodium chloride, is a non-volatile substance. So here we are doing, this is not the way, this is just another thing. Okay, just ignore this thing. This is your crystallization process. Okay, so sublimation is something when we are having two solid, ammonium chloride and your sodium chloride. We are having two substances which are in solid phase, and one should be your a volatile substance and another should be your non-volatile substance. And one volatile substance can be just vaporized and the another one will left behind. So sublimation is a technique to convert solid into gas or gas into solid, you can say. Okay, next question, second last question. So answer it quickly. Mixture of two or more metals or metals and non-metal called as metalloids, alloys, mixture, metallic mixture. What do you think? What is the answer? Come on, quickly. Mixture of two or more metals or a metal and a non-metal. What do you think? It is a metalloid, alloy, mixture or metallic mixture. The definition, this is one of the definition of the options. So Kartika is saying B, alloys. Okay. So yes, that's correct. B is the answer, alloys. Alloys are the mixture of two or more metals or a metal and a non-metal. So can you tell me, are alloys a homogeneous mixture or heterogeneous mixture? Quickly, A or B? Homogeneous mixture or heterogeneous mixture? Answer it quickly. Alloys are homogeneous mixture or heterogeneous mixture? Homogeneous, Nishant, that's correct. You can't find the layer of separation. Okay, in heterogeneous mixture, we find the layer of separation, but in homogeneous mixture, they are uniform throughout the solution. So in alloys, we are having two or more metals or a metal and a non-metal which are having a homogeneous phase. Okay, yes, Kartika, that's correct. It's homogeneous. Now the last question of this session. If the amount of solute contained in the solution is less than the saturation level, this type of solution is known as saturated solution, homogeneous solution, unsaturated solution, or heterogeneous solution. What do you think? What do you think? This type of solution is known saturated, homogeneous, unsaturated, or heterogeneous. How can we separate alloys? So basically, we are having this homogeneous mixture. Okay. Now, what we do, we just melt the product, what we are having, the alloys as a product, then we melt it. Then there are many procedures which you will be studying in your metallurgy chapter. Okay, this metallurgy chapter. Then you will find various ways. There are not simply a simple way. There are many ways in which you can just separate these alloys. Okay, so we can separate. Not all alloys can be distinguishable or separable. Some of the alloys we can separate. Okay, Nishan. So here answer is unsaturated, and another answer from Kartika Chaya Devi. What's your answer? So if the amount of solute contained in the solution is less than the saturation level, look how the question is framed. That if you are having the amount of solute in the solution is less than the saturation level, that means we are having a saturation level. What does this saturation level means? That no more solute can be dissolved. No more solute can be dissolved. But it is saying that more amount of solute you can add into the solution. More amount of solute you can add into the solution. So this is your unsaturated solution. This is your unsaturated solution. So what is the difference between saturated and unsaturated? Saturated means when you can't dissolve more amount of solute in it. This will be your saturated. And what about unsaturated? You can add more amount of solute in it. Okay, so this will be your unsaturated solution. Yes, Chaya Devi, that's B option, not correct. It's C, unsaturated solution. It's not considered as your homogeneous. It is asking for the amount of solute. Pavni, hi, how are you? You are late, I think. You have not answered. So nice to meet you, Pavni. Kartika, Nishant, Chaya Devi, very active participation, I must say. So this is the schedule. So we will meet on 11 November on Thursday for the session 2. Okay, I hope you like this session. So class timing is at 5:30 p.m. Do join and we will be discussing more questions over it. Okay, so thank you for your active participation. I really like this thing that when you participate, you get to know more and more things. Okay, so I hope you like the session. Hit like, subscribe, and just enjoy. And Nishant, all the best for your exam. Okay, I hope these questions will definitely help you in your exam. So thank you. Bye bye. Good night.